Hey, trigonometry. I had some questions. People wanted a couple examples, and these two questions particularly. So I just wanted to walk you through a couple of the practice problems. These were later on in the more challenging section. So let's get into it. So this is page 246, problem number 56, and we're supposed to establish each identity. So you'll see on this left side we have this huge mess of ugliness. And on the right side, we have a pretty ugly thing in itself, this for you action. I like this problem as good practice in substitution. Now, we use this a lot in calculus, where we're going to substitute an argument for something that we can understand a little bit better. So here you can see what I did down there. I said, unlike before when we were verifying identities, now we just want to try to find the easiest route to make one side look like the other. So on this one, I see an opening right here because 2 times 2 is 4. So I see that this is a double angle formula in itself, okay? So what I want to do is I want to think of this 4u as really 2 times 2u. And then I'm really thinking that 2u is really like a theta, right? So it's really like saying sine of 2 times theta. So really, I could rewrite it using this double angle formula, where if I think of this, the sine 4u, if I think of it broke down like this, it's really like sine of 2 theta, right? Like this. So then I'm going to use the right side of it. So you can see I'm verifying the right side, see where my equal sign is, to write the right side here. So instead of writing this, I want to write this. And now my 2 theta is, well, there's theta and there's theta. But remember, theta is 2u for us. So really, it's like saying 2 sine of this theta and cosine of this theta. Then we're going to use those guys' double angle formulas. Go look these up. So sine's double angle formula is right here. And now it's 2 of this theta, which is u. Oh, okay. So now we can write it in terms of one angle, just the u. And then cosine's double angle formula is right here. And then this 2, this constant, just kind of gets thrown to the front. But then you can see they wrapped it into this number. So 2 times 2. Remember, constants are pretty weak. We just put them in the front, or if they're additive, we throw them in the back, right? And they apply at the very end. And we can make them look however we want. All right? So there's 56. 63 was a little harder. Same game, though. Okay, so instead I worked on the right side, and I saw that this is a version of our half angle formula. It's on page 242. So instead of tangent squared of this half angle, I'm going to write this cosine junk instead. So 1 minus, see how I changed the tangent squared to this on the top and the bottom. Then I'm just killing fractions like we've done before, right? So I'm just making a common denominator here, multiplying by the reciprocal, getting some nice cancellation when I do that, and I get cosine alone. So again, the key here was finding the easiest in. I see this squared at a half angle. Man, that's pretty unique. Go find that formula that looks like it. Oh, there it is. Then I'm going to change that to the right side. And I love it because, look, it's made theta all by itself, right? The problem here is the theta divided by 2. So with these problems of establishing the identity, we're looking for an easy route in to break up an angle, an argument, to something that we understand better, like maybe a couple easier arguments like sums, or maybe a difference, or maybe a double or a half of that, right? So that's always the game we're trying to play. All right, email me any more questions that you might have, and we're starting to get to wrap this unit up. Remember, memorize identities, formulas. We're always going to have that resource, so just go look them up in your book. Okay, thanks.